Hi, everybody. Thanks for joining me today. One of the best tools a conservation biologist has is the ability to designate protected areas for wildlife. Today, we're going to consider conservation in some protected and also unprotected areas and kind of consider the consequences, the benefits, and again, consequences of both of those places. The legal definition of a protected area is a clearly defined geographical space recognized, dedicated, and managed through legal or other effective means to achieve the long term conservation of nature with associated ecosystem services and values. And that's a mouthful. So I put the next bullet point here. In other words, a dedicated, protected chunk of habitat protected area. According to the World Resources Institute, preserving ecosystems involves the following five main priorities. One, establishing individual protected areas. Two, creating networks of these protected areas. Three, managing those areas effectively. Four, implementing conservation measures outside of the protected areas. And five, restoring biological communities in degraded habitats. We're going to focus on 1 through 4 in today's lecture. The IUCN has developed this 6 category system, which is presented for you in your chapter in table 9.1, for classifying different kinds of protected areas. The conservation of nature in protected areas is a primary management priority in all 6 of these categories, with lands in categories 1 through 4 considered strictly protected. Lands in categories 5 and 6 are alternately considered multiple use, as their purpose involves conservation of biodiversity and the production of natural resources, like timber and cattle for human use. These multi-use areas are actually really significant, primarily because they're typically very large in size, meaning that they contain a wide variety of species, and they're often near or in the vicinity of other protected areas. And because they benefit people, they're most likely to have widespread human support. This top figure shows you the increase in the amount of area in protected areas in terrestrial, which is green, and marine, which is the blue line, protected areas. The global map below shows the percentage of protected ecoregions around the world. And again, green is terrestrial and blue is marine. And the darker colors indicate those that are closest to reaching their target goals. So this just kind of gives you an idea globally of where protected areas occur. And really, I think the low percentage of protected areas that we have. Gap analysis is a method that compares biodiversity priorities with existing and proposed protected areas, and it can consider several factors. Conservationists often use this systematic planning process that's described in detail in this chapter in your text, involving gap analysis. The overall goal in gap analysis is to identify gaps in current conservation measures and to mitigate those gaps. Here is a visualization of the first 3 steps of gap analysis, identifying where protection is needed for these animal and plant groups. This figure shows the proportion of threatened species that receive protection. Some threatened species lack protection across their range. Most have some partial protection, but few are completely protected. Okay, in order to evaluate where protected areas should even be located in the first place, as well as um, where gaps exist, GIS, which is Geographic Information Systems, mapping has become a vital tool for conservation biologists. If you have not heard of GIS analysis, this is something that you should familiarize yourself with. In the field, handheld GPS, global positioning units, can be used to collect data points, and then these data points can be input into a GIS, and you analyze and overlay the layers of different maps that are produced. Alternatively, aerial photographs and satellite data can also be used as input into GIS analysis for conservation. And here you can see what I mean by different layers of maps being shown. You can overlay vegetation with the distributions of endangered animal species, and then overlay that with where preserves are to get an idea of where gaps exist. The design of reserves is of utmost interest to conservation biologists and those that conservation biologists work with. We often consider what are called the 4 R's in establishing reserves for nature. Number one is representation. Protected areas should contain many different features or levels of biodiversity, like species, habitats, populations, etc. Protected areas should be large enough to maintain biodiversity into the future. We call this second R resiliency. The third R is redundancy. Protected areas must include enough examples of biodiversity to ensure long term existence into the future. So, redundancy. And then the fourth R is reality. There must be sufficient funding and political will to acquire the lands and then manage and protect them into the future. So these are the 4 R's. And this is one of my favorite figures as a conservation biologist with a background in habitat fragmentation. This shows different principles of reserve design. Principles of reserve design are based on the theories of island biogeography, which we introduced briefly earlier this semester when discussing habitat loss and fragmentation. So you can imagine nature reserves as being islands, and we can examine various design options by thinking of these reserves as being islands. And some are going to be better than other options. And this figure shows you a contrast of which would be a better option and which would be worse. For example, C, or let's look at B. A smaller reserve is going to be worse than a larger reserve in general. A fragmented reserve, C, is going to be worse than an unfragmented reserve. Fewer reserves are worse than more reserves, and so on and so forth. So I'd like for you to become generally familiar with this figure showing different reserve designs. An early debate in the 1980s in conservation biology and also in island biogeography is the question of which is better, a single large reserve or several small connected reserves. And this is known as the SLOS debate. You can read about this some more in your chapter. SLOS stands for single large or several small, SLOSS. We now know that large reserves are better, especially for mammal species, for a number of reasons, including edge effects, just the overall size of the habitat will increase how many individuals it can um, support. However, several small reserves are better than none when that's the option. And they also might be better for protected rare and endangered species. Over the next 100 years, small parks like Bryce, shown here in the diagram in the upper left hand portion of where the best fit line falls, in this diagram, are predicted to lose over 30% of the mammal species present in them. Whereas large parks like Yosemite and others, Grand Teton, are only expected to lose around 5%. One way to connect patches of natural habitat is through the establishment of habitat or wildlife corridors. Here are the migration routes of some East African species shown through what we call migration corridors, or in this diagram, they're labeled wildlife movement routes. Human settlements and agriculture, you can see the orange and the purple colors on the map, um, severely threatened corridors in the east. That's why those movement routes are designated as in red as highly threatened. So, when that's the case, some conservation biologists argue that we must find ways to promote the protection of biodiversity in these human dominated areas. And considering how much of the planet is dominated by humans, this seems like something we're going to have to achieve. And this idea is called reconciliation ecology. It was proposed in the early 2000s by Dr. Michael Rosenzweig. And this idea incorporates wildlife into human dominated landscapes, like adding pollinator habitat to solar panel fields or creating rooftop gardens. Sorry, I forgot to advance my slide there. And this is showing you the pollinator habitat and large solar panels. When solar panels are built in these large acreages, a new technique is to add pollinator habitat under them to promote pollinator conservation. So here's an animal with which you are familiar. The Florida panther provides a great example of protecting a species in unprotected habitat. This endangered subspecies of mountain lion lives in South Florida, as you know, and currently has a population of about 120 to 200 adults, which has actually increased in number since recovery efforts began in early 2014. In fact, back when they were listed in 1967, they were listed with the Endangered Species Act. There were only 20 individuals, and this is why they became very subject to severe inbreeding. What this figure highlights are the blue portions in the figure, which show suitable breeding habitat, and the orange dot represent actual radio telemetry records from 17 collared panthers back in 2017 and 2018. And you can look closely and see that there are black lines that are delineating protected areas. So most of the orange that you see occur in unprotected areas. Most of the orange and most of the suitable breeding habitat. Many native species occur in areas that are not being protected for biodiversity, but are being protected for some alternate purpose. And one good example is a military installment. And the great example of a highly endangered butterfly, the St. Francis satyr. The St. Francis Satyr only occurs at Fort Bragg, North Carolina, and this butterfly only lives as an adult for 3 days, lending to its extreme rarity. The species was found to actually thrive under disturbance regimes. This was found specifically at the artillery range of Fort Bragg, which is counterintuitive. You would think that the most protected and preserved areas would be important, but this species requires frequent disturbance. And in nature, it would be fire. And so at the artillery range, um, naturally occurring small wildfires will frequently occur and flare up. And this opens up habitat for this special butterfly. And I've linked a 17-minute interview with the researchers you see here below. One of them is Dr. Nick Haddad. He was actually on my master's committee when I studied butterflies and habitat fragmentation. This is a story from, I think, 2020, where he did some work with the endangered St. Francis Satyr at Fort Bragg. I'd like for you to listen to the story either through this link, which is in your notes, or I also have a link posted under the module on Canvas. Resource managers around the world are being encouraged to think on larger geographic scales than we've been thinking to this point, especially given things like the climate-driven range shifts of species and ecosystems that are predicted in the future and that we're already seeing happen. So we're seeing a shift toward ecosystem management, a system of large scale management involving multiple stakeholders. The goal is to protect ecosystem services while still serving human needs. And in this example that you're looking at, a watershed would be managed for a wide variety of purposes, both human and protecting natural areas for wildlife. So this is what an example of ecosystem management would look like. Finally, I think that it's really important to mention that working with local residents is absolutely key to meeting conservation goals. TEK, traditional ecological knowledge, refers to the understanding by indigenous peoples of ecosystems and management gained over millennia of experience of living on the land in close partnership. The partnership of traditional people, government agencies, and conservation organizations working together is what we call co-management. This involves traditional ecological knowledge and specifically not just taking the native lands from indigenous peoples and, quote, preserving them, which we would call eco-colonialism. The involvement of local peoples in the conservation of their lands is an issue of social justice, and it should absolutely be respected and maintained. All right, well, that was a quick dive into protected and unprotected lands, and I hope that you enjoyed learning a little bit more about chapters 9 and 10. Thanks for listening.